Acceleration. Now here's where it gets slightly a little bit more complicated just because the units are kind of confusing, which I also got confused when I was first learning physics. So we have acceleration equals rate of change of velocity over time. Very hard to put into words, right? Rate of change of velocity. So let's illustrate it. So let's say this car is traveling at 5 miles. Actually, let's not use miles per hour. Let's use the metric system. And everyone knows we use meters over seconds. So let's say this car is traveling at 5 meters per second. That's probably, I'm not sure if that's accurate because I haven't done the math conversions in my head to know if a car actually travels at that speed. But let's just assume so. So it travels 5 meters per second. So what that means is that it's traveling 5 meters per second. It's pretty self-explanatory. But let's say it speeds up to 20 meters per second. Now it's traveling 15 meters more per second than it was before. And let's say accelerated to that, or it went to that speed over an interval of 5 seconds. So it went from 5 meters second to 20 meters per second in 5 seconds. Let's do the math. So it changed 15 meters per second per 5 seconds. And if we use dimensional analysis, we get 3 meters per second squared. So the acceleration will be 3 meters per divided by second squared. Sounds a little bit strange, right? Second squared. Do we plug the time into here? No, that's just the unit analysis. So that means when you times it by like 5 seconds, the s's cancel out, giving us a change of 15 meters per second in velocity. So the only reason this is there is because when you times it by another unit of time, we can cancel out the s, leaving behind a change in velocity when we cancel out the s, because the s's cancel out, leaving us meters per second, which is the overall net change to velocity. So simple logic there. Unit term slash s squared. Formula equals average acceleration, blah blah blah. That's the same thing as that, which I don't know why. It's the same exact thing, so there's a logic there. So yeah, that's it. Um, but note that we do deal with average velocity, not velocity here in that instance. So there's your logic there. Pretty simple physics. So.